Next on TechStack, we have 4 new supercomputers and we have a brand new rack level system architecture for AI. Welcome to TechStack. I'm Jim McGregor from Tirias Research. I'm joined by my esteemed colleagues, Mr. High Roller Mark Vena from Smart Tech Research, and the man, the myth, the legend, Mr. Marco Chiappetta from Hot Tech Vision and Analysis. Gentlemen, thank you for joining me. Hey, I almost feel we're going to talk about data center stuff today, and I almost feel like saying that there's news in the data center is like saying the sun came up today. Anybody else feel that way?
This week, especially, monster news, like 3 huge announcements that we're going to talk about here, and that's like the tip of the iceberg. Absolutely.
Yeah, and we're just coming off these huge announcements by AMD and Nvidia doing this kind of joint investment / partnership with OpenAI, and now we have these announcements. So let's start off with the first one. The first one is Qualcomm. Qualcomm jumping in, and they've already kind of indicated this, and so this is nothing new. We knew this was coming, but they're jumping into the AI data center fray in a big way with new rack level solutions. They announced an AI200 and AI250. The 200 coming out in 2026 and the 250 coming out in 2027. Now, they didn't give a lot of details on these solutions, but what we know is the fact that they're going to be based on their new CPU and their new NPU accelerators, and they're going to be using accelerator add-in cards and the and PCI Express as the scale-up backplane. Now, and it's going to be liquid cooled as well. So these are going to be full rack scaled solutions that they're going to be marketing out there in the market. And they have one design win with Humane. So the first system is going to be over in the Middle East. So gentlemen, what's your take on it? What do you think, Mark?
Well, my first observation, and you mentioned the word, I'm not a holy roller or whatever phrase you use, Jim, but I think
high roller.
Yeah, but it's interesting. Since we're going to talk about supercomputers, I wish Qualcomm or any one of the companies that we're going to be talking about, I'll volunteer for them to install a small version of it in my house. That way I can figure out the odds better here in Las Vegas.
I think all those lights behind you would dim if they did that.
You know what? You're right. But we do have the Hoover Dam, so we do have a lot of electricity that we can kind of marshal for the project. But the interesting observation about Qualcomm specifically is, yes, you're right that this is not new news because they've hinted at it, but they are kind of the new player on the block in the data center. I mean, they've been pretty much a mobile device player. Not that that's been strictly their focus, but that's kind of where their roots are. And the question that I would love you guys to chime in on is, even though they're coming kind of late to the party, the installations we're talking about, and we're going to get into some of this DoE related stuff that these announcements were made. These are not trivial installations, and the government doesn't make commitments unless they really believe the vendor has the application chops, the technology chops. There's infrastructure things that we'll certainly talk about. And Qualcomm is kind of new to the party. I do think that they will have a role there. But when you're late to the party, you've got to prove certain things. Is there a value proposition from a cost standpoint? Although, the government tends to like to throw cost of the wind when they're working on these big supercomputer projects. So that's, to me, the fascinating thing is that since Qualcomm is relatively new to this space, how long will it take him to get credibility to kind of, step on the toes of the Nvidias of the world, and even the AMDs of the world for that matter, to be able to be a credible presence? So I actually throw that question back to one of you guys.
I think we'll get to that. But first, I want to ask one question to Marco on the technical side. They didn't give us a lot of tech specs on this. So even evaluating, its potential at this point in time is kind of difficult. They did say that we're going to have, they're focused on near memory compute for the AI200 and some innovative memory architecture. No details, once again, for the AI250. So, obviously this is targeted towards inference processing. But what's your take on it, Marco?
So my take is Qualcomm's going straight for the high dollar installations, right? No, there's no massive spends on individual accelerators. So they're shooting right for the rack scale solutions. In terms of technical details here, so we know that the AI200 is going to have 768 gigs of LPDDR memory, so massive amount of memory per accelerator. And this near memory compute capability, fuzzy on details. If I were to speculate, right? So the claims that Qualcomm is making is massive boost to effective memory bandwidth. Now, we've heard stuff like that before in GPUs. If you look at something like, say, AMD's Infinity Cache on the consumer side, it's basically a relatively large pool of memory in the memory controller, right, that acts as a cache to boost effective bandwidth by limiting traffic across the memory bus. Qualcomm's probably going to do something like that because not only does that save power, it boosts the effective bandwidth available for that massive pool of memory. Can they pull it off? Probably, right? It's not something we've seen from them before, but this is not a brand new sort of concept. And the thing they have going for them as well, as you mentioned, is they're using PCI Express for scale up and Ethernet for scale out. So they're not developing some sort of new interconnects here. So I think they're going to be able to pull off the hardware. The innovative features, we'll have to wait and see exactly what the architectures hold. It's really going to come down to the software, not Qualcomm pulling it off, I think.
Well, and one thing that Mark brought up was, can they do it? I think we should point out that Qualcomm never does anything alone. And obviously at a data center scale, you have to have partners. So I'm sure that they've got, the power, the system designers, the cooling solutions. I'm sure that there's a lot of partners in there because I know they didn't develop these racks by themselves. So I'm sure that they can do it. Nobody's better at building an ecosystem around their products than Qualcomm. The big question, though, is Wall Street has is there room for a third major rack level provider? Or quite honestly, this may just be the third of 20 different level solutions we see coming. We never know what's going to be coming next week. So do you think there's room for many or multiple providers in this segment?
At this stage, I would say yes, right? We're still in, as much as we've been talking about it and as fast as it's accelerating and how much money's being spent in this space, we're still in the infancy here, right? So there's going to be innovative ways to do the compute. There's going to be new ways to handle memory. Someone is going to come out with, a new framework that accelerates things. So things are moving too quickly to say, okay, this is only a 1 or 2 horse race. Yeah, NVIDIA is currently the 800-pound gorilla, but the tech scene is a finicky scene, and all it takes is one stumble and someone else to come out with innovative technology to sort of shift the whole landscape. So at this stage of the game, I think there is still room for other players. But like any industry, it will eventually kind of shake out and settle down to maybe a 3 or 4 horse race.
Right.
Any other comments, Mark?
Yeah, I mean, I agree 100% with Marco. I think this is a brand new space. We kind of think that AI. I think we've kind of seduced ourselves into thinking that this category is mature. It's not a mature category from a market standpoint. So I think absolutely that I think there could be multiple players there. Do I think that there could be 25 major players in this space? No. I mean, first of all, and Jim, you kind of referred to it, is that to play ball here, you got to have a pretty strong farm system, just to use sports analogies here, since we're on the call and the World Series just ended. But the reality is that there's not many companies that have the chops. They have to figure out how they position themselves. Everything both of you have said is absolutely true. It may take some time for Qualcomm to solidify all the things they need, which is probably the explanation why they've been a bit vague. But if anybody can pull it off, Qualcomm has they've been on a very upward trajectory from a technology implementation standpoint. They've got a lot of experience, and I think Cristiano realizes that the play ball here, it's a major undertaking, and they'll probably release additional information over the next 3, 4, 5 months that will kind of solidify their story. But I absolutely believe that there is a place there. what it comes down to in many cases is cost. I keep going back to that over and over again. And Nvidia is the 800-pound gorilla. Nvidia also is the not the cost leader. I mean, they are the premium leader from a cost standpoint. And whenever you have any market where you have 80-90% share of that market, and certainly Nvidia is in that is in those lofty in that lofty category, there's going to be other folks going to have to use pricing as an element to be the more affordable approach. So I absolutely agree with Marco's thoughts on this.
And we should probably remind our viewers of the fact that there's never been a single server CPU architecture for servers in the industry, because no two workloads are the same. So we've always had a bunch of RISC and CISC architectures for the CPU. The same is likely going to be the same for AI, with different size models, different functioning models. There's going to be a lot of opportunity for different accelerators based on different performance requirements, power requirements, even location is probably going to play a factor in what you use and how you use it. So let's move on. Next one, and this one really excites me, is the fact that we saw two announcements from the Department of Energy, one with AMD, one with Nvidia, talking about 4, not 1 or 2, 4 brand new supercomputers. Now, just to remind you, the Department of Energy has 3 of the top supercomputers on the top 500 list now. So now we're announcing 4 with, 2 with AMD, 2 with Nvidia. Marco, you want to dive into these?
Yeah, where do you want me to start? AMD or Nvidia? You pick.
Let's start with the AMD one. AMD has a long history with working with the Department of Energy. They have the number 1 and number 2 supercomputers on the list at Lawrence Livermore with El Capitan, and at Oak Ridge with Frontier. So where do we go from here?
So we go to Oak Ridge again, because both of the systems that were announced are going to land at Oak Ridge National Labs, alongside Frontier. And as you mentioned, AMD's got 2 systems in the works with the DoE in partnership with Oracle and HPE, right? So there's going to be the Lux supercomputer is coming first in 2026, and then coming later a more powerful machine called Discovery. And Discovery is going to use basically all next-gen hardware. So the EPYC next-gen Zen 6 based EPYC CPUs built on 2 nanometer, and a new MI400 class GPU, the MI430X. So as I mentioned, Lux is coming first, and that's going to be based on existing hardware. Again, AMD EPYC CPUs, but MI300 series accelerators. That's going to come online in 2026. Now, we don't have the number of GPUs or expected performance levels here, but it's not going to be, it's not going to be some low-level system. This is laying the foundation for the big next-gen Discovery system. So that's coming online first. Now, Discovery is probably where most of the interests lie, because it's essentially, entirely new platform, all new tech. It's HPE's Cray supercomputer GX5000 platform, using Oracle Cloud Infrastructure with 2 nanometer EPYC Venice CPUs, and as I mentioned, that MI430X GPUs. For the DoE to jump on board with this, with all new tech, it's probably a little bit of risk there, but that seems like it's going to be really, Frontier is already number 2 at Oak Ridge National Labs in the top 500. Discoveries, and that's using MI250s, right? So a few generations back. This guy is probably going to be a monster. Like, Discovery is probably going to be a ultra powerful AI supercomputer, is really the only way to put it.
And we should probably note that when the DoE builds these supercomputers, no matter who they're working with, number 3 on the list is actually in Argonne with it's the Aurora with Intel. All of those 3 top systems, none of them were completely off-the-shelf hardware. They were somewhat customized. So you mentioned that this is going to be next generation. They called out a number called the MI430, and we've never seen that number before. So We're not quite sure what that is, but obviously it's something that's really going to be tailored towards the DoE. And I wouldn't expect them to build a supercomputer unless it's going to leapfrog the next ones. Mark, what do you think?
Well, here's a question that I have that and I think I know what the answer is, but I'd love to get your guys' feedback to this. Is that when you're talking about supercomputer installations at the Department of Energy, no less, you wonder, is the focus purely on technology performance versus value? And I guess the question, AMD, for example, and their value proposition at the end of the day is cost, certainly at the enterprise level. But the question I have for both of you is that at a Department of Energy installation level, and this is not just a data center. This is a massive, massive undertaking to solve some of the technology problems that are posed that the Department of Energy would encounter. Is really cost a factor, or is the classic difference between an NVIDIA implementation and an AMD implementation is that NVIDIA tends to be more proprietary. They like to lock you in, where AMD tends to be a bit more, not a bit more, but certainly more open from an implementation standpoint. So, Jim, what's your thoughts on that? What is at the DOE level? Are they more concerned about performance? Hey, performance at all costs. We don't care what the costs are because we're the government. Or is value a component to this?
No, I think performance is the key driver here. They're trying to enable scientists at the national level to be able to do all kinds of things, from climate research to materials research to you name it. Matter of fact, when they talked about these systems, they labeled Lux not just as an HPC computer, but as an AI factory. So they are actually designing these to be, very performant in very specific ways. And the DOE usually tries to make all their systems work together. So you may be running one workload on one system in one area and another workload on another system in another location. They are definitely trying to enable, new discoveries, new research, new enablement, for scientists. And no, I definitely believe that performance is the overall factor. I'm sure there's a value component there, but I think it's pretty low on the list. What do you think, Marco?
So there's actually another wrinkle too to keep in mind here. So in July, the Trump administration came out with the US AI Action Plan, and it basically lays the foundation to accelerate the US's leadership in AI and sovereign AI, here on US soil. Now, and the other thing to keep in mind with both of these announcements too, the DOE's got a new public-private sort of partnership model. So it's not strictly going to be used for government. These systems aren't strictly for government research. There will be public investment dollars too. So that kind of throws off all of the traditional math equations here. I do suspect, though, that performance is a key factor, right? If you're going to build these massive systems, you want them to have leadership positions, right? Especially when an administration like this is involved, who's maybe a little blustery, just a bit, and likes to brag about things. So yeah, these the cost model, who knows what it's going to be? They're probably going to throw tons of money. We know it's $1 billion going to AMD. It's a $1 billion partnership at this point. I don't think Nvidia talked dollars yet, though.
Yeah.
And not to be outdone, NVIDIA had their own announcement with the Department of Energy for the Argonne National Laboratory and Oracle to build 2 AI supercomputers, one called Equinox and the other one called Solstice. Solstice having up to 100,000 NVIDIA Blackwell GPUs. Once again, we didn't get a lot of detail into what the overall configuration is. This is going to be using existing generation. Kind of surprised it didn't include Rubin. But they plan on building this out over the next 2 years. Any other detail I'm missing here, Marco?
Not really. The specifics of the hardware weren't in the release. But since we know that the smaller of the 2 systems, right, is Equinox 10,000 Blackwell GPUs, that's coming first in 2026. Probably going to be GB200. I'm going to assume. I'm guessing. Don't have any confirmation. The bigger Solstice system, though, NVIDIA did claim it's going to be the DOE's most powerful AI supercomputer. Maybe that's GB300 Ultra. not sure, but they did specify Blackwell. So, as you mentioned, at this moment in time, Rubin is probably not part of the conversation for these systems.
And one interesting note about these two different announcements is the fact that both of them had Oracle. So I almost think that Oracle is the big winner here. Mark, what do you think?
So,
Marco, go ahead.
I was going to say, Oracle's their cloud infrastructure is really the software that enables all of this for all four of these systems being built. Right. So, Oracle is definitely a big winner in this for sure.
No, they're the common denominator. I mean, let's face it. Go ahead, Jim.
And not just the software, but also having that, they're kind of a great data warehouse. I mean, they're a huge data warehouse. OCI is. So I kind of see that as kind of being one of these core building blocks that, a lot of the announcements definitely go towards, I think, AMD and HPE and Nvidia. But let's face it, Oracle is definitely a key player in these systems. And we're going to have four brand new supercomputers. And I would expect, I don't know, do you think that they're going to top El Capitan? How many of these should we expect to be in the top 100 or top 10?
Right. So who knows, right? So this is what's nuts. Like when you hear about these supercomputers, but you don't really see the details. Like Frontier, the number 2 system, has over 9 million cores, right? El Capitan is over 11 million cores. Now, the next gen EPYC processors, right? They're going to be up to 256 cores per socket on the CPU side, right? So 512 cores per 2U system. I mean, these aren't going to be standard off-the-shelf systems, obviously, but there's potential. Now, let me just also say, like, Frontier is using 64 core EPYCs, right? And the El Capitan is only 24 core, but they're the MI300A class, so CPU GPU hybrids. So we know there's going to be much more compute on the GPU side. We really can't forget CPU here either, right? Because there's a lot going on with these systems. There could be a huge uplift on the CPU side too. I'm not going to guess. I'm going to say though, the two big systems, right, are probably going to be leading edge machines that end up on the top of some list.
Well, I would also say, though, by the way, and you alluded to it, Jim, is that when you look at the big public sector challenges, is that these kind of platforms provide is the real. I mean, just think about in history, the amount of power that was needed to solve a lot of the complex problems in the making of the atomic bomb, the Manhattan Project, and of course, the devices they had back then were not much better than even basic calculators, and it was very, very manual. Now you talk about the landing on the moon required tremendous amount of computational power to run different types of scenarios. And when you look at the fact that the current administration, we're going back to the moon, there are thoughts about going to Mars. There, Marco talks about justifiably with a lot of awe the amount of power behind this. Those kind of capabilities are going to be needed to be able to simulate some of the and solve some of the problems that we can't even contemplate, frankly. So it's awesome to think about it, but when you think about some of these public service projects that are being contemplated, this stuff is going to be needed. It's going to almost be a requirement.
I'm excited about this, not just because of this, but we have supercomputing right around the corner. I know that there's going to be a lot more about the revisions in the top 500, as well as a lot of talk about quantum computing and everything else. So there's going to be a lot. Once again, there's so much going on. It's hard to even narrow it down to just a few topics for each episode here, but this is huge. I'm excited. Anytime somebody says, supercomputer, I get kind of excited.
Can I just give like a couple little numbers just to give a sense of scale?
Go for it.
So like an NV32 rack, right? Or let's use one of the examples from this podcast. So Qualcomm's rack, they're targeting 160 kilowatts, right? The Frontier supercomputer, the number 2, is 24,607 kilowatts. The top supercomputer is 29,581 kilowatts of power. These are massive installations, right? This is an insane amount of power that's going to be required. And you can bet these newer machines, even though they're more efficient, are going to use even more than that, right? So we're talking the scale that most people, you can't even comprehend the scale of these systems. They're just monsters.
I'm almost surprised that we're not seeing announcements about new nuclear reactors going up next to these labs at this point.
That's coming next.
That's coming. That's coming.
Well, the government is trying to further SMR, small modular reactors, and trying to get them into market as quickly as possible. So we may actually see those deployed to some of these national labs pretty quickly, just to be able to power these systems. It is incredible. So no, the size, the power, and no, these are not going to be the all-knowing intelligence that sci-fi likes to envision, but they are going to solve
Colossus, the Forbin project.
When that happens, they'll have to name it the McGregor supercomputer.
There you go. There you go. I like that. But they are going to solve, I mean, just thinking back to COVID and what we were able to do with DNA sequencing and being able to come up with vaccines and stuff very quickly. This is really going to help propel, I think, not just the U.S. in terms of its research and capabilities and competitiveness, but also industry, industry after industry, and what we can do and where we can go with technology.
Yeah, and one nuance in Nvidia's release, we didn't talk about it. It's actually it's only one sentence, but they say they want to enable agentic scientists, right? This isn't just about training frontier models. It's about building digital scientists, right, with super intelligence. And that's one of the goals, stated goals in NVIDIA's release with their DoE projects. So imagine now, a PhD gaining access to one of these, and at his side, he has an agentic AI with Einstein's intelligence or Stephen Hawking's intelligence. Now, I'm being a little bit facetious, but that's really what's coming, right? They're going to have digital assistants with the whole human intelligence at their disposal. So, I mean, this could enable some totally new use cases and really wild breakthroughs.
Not just human intelligence, but the compute capacity to run numbers beyond anything that we've ever imagined before.
Right.
Exactly. Yep.
No, this is exciting. So, gentlemen, thank you for joining me for another TechStack podcast. If you like this, please like and subscribe. If you have any recommendations on future podcasts, please send any one of us a message, and definitely follow us on our social media tracks, which have been scrolling across the bottom of the screen there as you watch this. Once again, thank you for joining us. TechStack out.